You made it for part three. And like, I think almost everybody that joined part one has made it through to parts two and three. So I'm honored. Hopefully everybody can hear me okay. One of my colleagues reminded me that I had this big fancy microphone and that I should actually use it when we're doing big events like this. So hopefully the audio is okay. Man, there's a lot of people in here. If you were all in one room, which would be very unsafe right now, it would be a giant auditorium. So this is much less intimidating. I'm glad. I like doing it this way. Um, Part three, we've come a long way. I'm not going to do a giant recap because if you've attended both of these already, you already know who we are, you already know who I am, and the first part of the story. I'm just going to show this really quickly because when we make the video and we post it up to YouTube later on in the day, this is where we'll splice in a bunch of the background. So my name is Chris. I'm based here in Calgary, so I run Nucomp's analytic business for Western Canada. Nucomp's head office is in Toronto, but we're all over North America and the Caribbean, which is why it's fun to bring together, 400 or 500 different experiences across all of our clients and condense it for you. So hopefully you have less false starts and you can borrow some ideas from us. My background is much like the story I'm going to tell today. I grew up in analytics before it was cool, and the world has changed, and I've had to adjust my knowledge and role, and then raise up other consultants and technologists in this new paradigm. So I'm going to give you some of the things and tools that I use to kind of get up to speed to be able to deploy analytics today. So Nucomp, I know I see tons of people on the line here that are already familiar with us and work with us and have for a long time. If you haven't, Nucomp only does analytics. Data is our world, and we've been doing that since the 90s, before my time. We don't specialize in any given industry or practice or department. Analytics is pervasive. So whether it's insurance or oil and gas or finance or HR, we are there and have been there. The technology partners on the bottom are very important to us. So obviously we can't be experts in everything. That's not to say we don't have technical skills in a bunch of other technologies. These are the ones that we've decided to kind of bet on, that we are seeing win over and over. We're not early adopters. We wait until some of these technologies and vendors have really established themselves, and then we say, okay, we see a pattern there, especially in the Canadian market. This is viable, from a financial perspective, and the technology looks good and the organization looks good. We're going to invest. So I encourage you to check out some of those technologies if you're not already familiar with them. And finally, just to understand what makes up Nucomp, this is what we call our DNA. So you can think of these as our pillars or our practices within Nucomp. I spend a lot of my time in our BI and AI and open source practices. Our part two of this is going to focus, more on that data management side of it. So, what you're going to see today touches a lot of parts of what Nucomp does. And then, we've got dedicated practices for things like financial planning and doing, smarter forecasting, using analytics to do things that maybe were done manually in the past. So that's us. All right, let's get into it. I think a little bit of history is important just to understand how we got here. This is both me telling my story and just telling the story of analytics in general. In the 90s is really when the genesis of BI happened, right? So at that point, these were reports that were built by specialists. They were bringing together information and reports and then giving them out to non-technical users, right? And that was really the structure. It was this kind of bottleneck, centralized, build a report or a model or a cube or whatever, and then give it to a non-technical user. And that got us so far. I think the appetite was to get rid of that bottleneck. And so you kind of saw this shift both in attitude and technology towards self-service. So decentralizing that function. Maybe we're giving users, the ability, maybe not to create their own data sets initially, but to at least drag and drop and build their own visualization. It cuts out a lot of the back and forth in design. And that was great because anytime people get their hands on data, they obviously want more and they get hungry for it. And in the background, we're now into the 2010s, what was happening in the world? Well, data was exploding in the world, right? Data exhaust coming off of sensors and all of your web activity and every vehicle in your fleet and every machine in your manufacturing assembly line was generating massive amounts of data. And so maybe your organization wasn't experiencing that, but certainly the big Silicon Valley companies were, and they were building infrastructure to handle it. So, Google and Yahoo and kind of Facebook, these early pioneers of big data, built and open source technologies like Hadoop, which were built to handle and retrieve massive amounts of information, zettabyte scale. But they built that for themselves. They are engineering and software development firms. That was less accessible to a retail company in Canada or in the Netherlands. And so as they were building out those technologies, they realized, okay, we've got these massive investments in data centers and computing horsepower that just isn't accessible to the rest of the world. There's a business model here. And so that economy of scale allowed them to sell those services, so a database as a service or some computing horsepower or graph processing or whatever you need to do that uses big amounts of computing power. And they said, we'll turn that into a business model. So Amazon went from being a giant logistics and retail company to being a cloud computing company. And so, they can still make massive profits even if they charge you by the second, if you're just spinning up an instance for 11 seconds to run a machine learning algorithm, they're still making money. And so that's where we are with the cloud today. There's cloud service providers that have invested in this infrastructure and sell that as a service to you. And then the cloud itself is kind of causing this ripple effect as we go back and we look at all the ways we used to do things. Now we're re-engineering them. I just want us to agree. I made this kind of as a joke. I think everybody knows how to pronounce the word, but really the cloud, most simply, is just somebody else's computer. In our case, we're doing that over the internet, usually on one of the big cloud providers platforms. Not always the case. There's some smaller cloud providers too. And when we talk about service levels, I'll get there in a second, but generally the more you want the cloud service provider to do on your behalf, administration-wise, the more you pay for that service, okay? The cloud, somebody else's computers. There's a couple of different flavors of the cloud. Most of the time when we're talking about the cloud, we're talking about public cloud. So Google, AWS, Microsoft Azure, IBM Cloud, Salesforce, Alibaba. There's some big cloud providers out there. That's generally what we talk about when we talk about the cloud. That's not always the case. There's certainly private clouds. So if you go into the Pentagon, like the Department of Defense or Goldman Sachs, or organizations that are very strategic, very private, or they have very specific requirements around their data, they might choose to build a private cloud. So whether they host that or they pay somebody else to host the hardware, that's kind of disconnected from the public internet, public cloud. And then we've got the middle ground. So, IBM bought Red Hat for this very reason, is that we can sew together a private cloud and a public cloud services and make it look like one giant mesh of services. And so I just wanted to make sure you understood that terminology. So today, what are we going to go through? I am not reviewing a bunch of the, architecture changes. You guys are already very familiar with that. We're going to talk about specifically, it's under the label data engine here. This is really what you would think of as traditional data warehousing. Just how is that done today? How has the cloud changed the way that we prepare data for heavy query volumes? Not just for extremely technical users, but for non-technical users too. How do we plan and scale that so that it's, it's cheap when we're doing it very quick and small, and it's predictable when we're doing it at big scales for a lot of users. So we're going to talk a little bit about the platforms out there that are the data engines of today. Once we get our data into a structure like that, we're generally starting to define things like joins and relationships and applying more business rules to it. And so this is really where we're starting to apply those business rules, like I was saying. So joining tables together. So when I'm a user and I drag in product and sales metrics, sales revenue, I don't need to know that this key joins to that key in the table. We're defining that kind of behind the scenes for our users. So, non-technical users or more advanced analytics, they don't need to know the base relationships between those tables. We're also maybe combining tables like order detail and order header into one orders table, either physically or virtually for people. Usually we're doing this for ease of use. Sometimes we're doing it for performance reasons. We're managing things like levels of granularity here, And so we're going to go a lot into those business layers. When we talk about insights, now is when we've done all this work on a bunch of raw data to turn it into information. Now we got to get it into the hands of people. That used to mean, we talked about this, it used to mean building reports or building a static dashboard, gathering requirements, getting some sort of wireframe built, and then delivering it. And then eventually there would be change requests, and we change it, and then we give it to them again in version 2. We're trying to remove a lot of those barriers. A lot of that just was time and frustrating and bottlenecks and like I said, change management. We've got the tools now so that users can almost prototype what they want to see. And if we want to turn it into an official report that's sanctioned, sure, we'll feed it into our kind of official reporting folder. But I really think that last mile of BI, we can turn it over to users more and more now to say, you know what, we've prepared data the way that we think of it as a company or as an organization. You know your requirements best. Here's some really friendly tools for you to go and explore and augment and combine and mash up that data together and do what you need to do. If you need to figure out which students are going to drop out, like you don't have to explain that to the IT group so that they can build a workflow for you. You go build it yourself, and then if it's all verified and whatever, maybe we take that and we publish it for the rest of the institution to use. So just talking about how we deploy analytics into the business or kind of the end user hands these days. And then data science, we're going to talk about advanced analytics, tons of myths and hype and I think some misconceptions about what data science is and isn't. So I'm going to try and bust some of those down for us today. Let me go back here. We talked about this reference architecture. Hopefully it's burned into your retinas by now, but we did the first half of this and talked about ingestion, replication, and landing things into data lakes. We talked about data governance and all the types of data that we're trying to deal with. Now we're gonna go deeper on this part of the diagram. So once we have curated those data sets, how to package it up and get it into a warehouse or a data mart or whatever, how to augment it. So maybe we're giving this to a data scientist, they're creating a forecast and then pushing that back into our data set, or they're clustering, our customers together into cohorts or segments and then appending that to our data set. We're going to talk about how data kind of gets augmented. It's this living, breathing thing now, not a static table that lives in a database. And so this is the half of the pipeline we're really going to focus on. Okay. All right, so let's talk about this. All right, so and I think we went over this a little bit, but again, we're setting the stage for managing the different types of data that we deal with. So hopefully you all remember this. Structured data, we were talking about rows and columns, right? So retail transactions, our financial records, things coming from HR, very much what you would look at in Excel or in any of your corporate applications today. That's probably what lies underneath it, is some sort of structured data. When we talk about unstructured data, this is usually what we're referring to, things like images and videos and audio recordings from a call center, raw text like emails, for example. Sometimes emails might be considered semi-structured since they sometimes have a very predictable, a subject and a body, etc. But most of the time, this is what we're dealing with, things that have no discernible structure and, don't have an obvious analytical value until you do something with it. So, a picture we might recognize when someone picks up a piece of clothing in our retail store, and when they put it back on the shelf. We've got clients that do that. And so, instead of having RFID tags on everything, we can actually just use the video from the store to see who's picking stuff up, trying it on, and then putting it back. So we can train a model to recognize when those things are happening. That's the kind of data we're talking about, videos and images like that. Then there's data that kind of looks human readable. We're actually going to go through an example together of this data. But this is what we call semi-structured data. So if I gave it to you, you'd probably understand what it was, but if I told you to like break it out into rows and columns, you'd probably struggle. It's not data built like that. And this is data that we're dealing with way more now. Information coming off of sensors, data that we're buying, weather data, for example. A lot of the data that comes out of machine learning models, et cetera, or goes in and out, is in this JSON or XML format. And then metadata sometimes is just as big as the rest of the data set, right? Every single piece of data that we talked about in the first 3 steps here has metadata. Where did it come from? What type of file is it? How big is it? Who put it in there? What state is it in? Is it raw? Has it been transformed at all? What was the date that it was loaded? All those things are data about our data. And so I challenge you to think about your metadata. It has just as much value, I think, a lot of the time as the base data itself. This we haven't talked about so far. So I'm going to get a little bit deeper on the types of data. I'll call them databases, just for lack of a better term. And I don't want to start using really esoteric words, but that I'll start with something everybody's familiar with, relational data. So relational databases, very straightforward way of representing data. This is table data, so rows and columns. Every row of the table is a unique record, and it's uniquely identified by an ID called a key. You probably heard these terms before. The columns of that table hold the attributes of that row. So, color and size and shape and whatever. Every record usually has a value, even if it says, NA, it's not empty for each of those attributes. And that makes it really easy for us to establish a relationship between all the rows. So I say, for every customer, row, show me everybody that's in Ontario or in Alberta. And that allows me to group those rows together, right? And in each of these examples, I'm gonna throw up a bunch of technologies there just to help spark you. And you say, oh, that's my SQL database, or right now we're using DB2. That's exactly what we're using, and those are relational databases and data stores. Okay. Now we're getting into some more non-traditional types of data. So document-oriented databases are one of the main categories of something called NoSQL, which really means not only SQL. These are a subclass of something called a key value store, and that's another NoSQL database concept. But basically, a document store sounds exactly like it is if you think of like a Word document. It stores all information for a given record or object in a single instance in a database. And every stored object can be different from the others. What this allows us, we're going to talk about schemas in a second, but this allows us to load data just kind of as is. So, if you think of just everyday objects, my drums, which are sitting across from me here, have very different attributes than my laptop. And so if I was trying to jam both of those into an objects table, they'd have wildly different attributes, right? And so I might as well just store them and their attributes all together. And then when I want to join those two things together, I could say, well, show me all the laptops that are black and show me all the drums that are black. And then I could join them together. So I'm imposing a schema on them when I'm asking for information back. So that's the value of a document database. And I get that these are, if you don't work with data, these are pretty advanced concepts. So I'll try and go slowly and keep repeating myself. A graph database. What's an easy example? LinkedIn is an easy example. LinkedIn uses a graph database that they invented called Liquid, and the L and the I are capitalized for LinkedIn, but you should Google it. Graph databases are similar to a document database, but they add another layer, which is the relationship. So if you think of LinkedIn and how everybody is kind of connected, and it says you're 1 degree or 2 degrees away from this person, that is a graph database. It's a bunch of objects with relationships. And so it allows you to kind of rapidly traverse those trees of relationships, right? This is one we are seeing, you are all familiar with, which is the data warehouse, and has evolved over time. Nowadays, these are mostly cloud. Because of the nature of the engineering underneath a data warehouse, these are mostly cloud deployments. I haven't seen an on-premise data warehouse deployment or project in a number of years. Data warehouses are organized usually into, we separate our metrics or our facts from our attributes or our dimensions. And that allows us to do really quick retrieval. So we go to a small table first and say, show me all the products that are black, and then we go and join it to the transaction table, and that gives us a very limited set of records to go back instead of traversing all of our transactions for all time. Okay, so that's really the value of a data warehouse. A time series database, if any of you work with devices or sensors or vehicles or anything like that, you are for sure generating time series data. So this is like real-time snapshots of data. It's optimized for time-stamped data. Usually, I don't know, what's the best way to explain this? This is like trades in the market or uh, uh, readings off of a pressure or temperature sensor. So, what we're dealing with here are massive volumes. You can imagine the volume of data that comes off of a pressure sensor that's, sampling every hundredth of a second. We're generating a lot of records. Um, Generally we are not looking, we are looking for patterns in this data, or we're aggregating it. So each record individually isn't that important to us. What is important is if the slope changes. So if pressure starts to get faster or higher at a more rapid rate, we're interested in the slope of those changes. So that makes that database a little unique. And then a key value store. This is managing something called associative arrays. If you're into data and computer science, these data structures are usually called dictionaries or hash tables. So those dictionaries are a collection of objects or records, which in turn have fields inside of them. It's a little bit of an abstract concept. Wikipedia actually has a really good page on key value stores, but that key itself allows us to go find that dictionary or that instance of an object. So it's way too much to go into on it. I just want you to make sure that you're aware of it. Go Google it, and it'll give you some examples, and you'll think, oh, we've got data just like that. But those are the 6, and there's many, many, many more of these, but these are the ones I wanted to highlight. And it's not scary. So when I was talking about semi-structured data, if you look on the left-hand side, that is what the reading from a weather station looks like. And that's in JSON format. And I've got 2 examples of BI tools. I think the top one is Power BI, yeah, and Tableau on the bottom. Those tools connect by default natively to JSON files. So you can literally just drag and drop it in. You say, here's my attributes, and you could plot it right away in a couple of seconds. So I'm not going to give homework this time because I can't check in on you. But this is something I encourage you to do. You could actually go to Kaggle and download a whole bunch of JSON data, and then just drag it into your BI tool and see what happens. But it's not that scary. You guys can see that, that data on the left-hand side, it's got a bunch of attributes. They're grouped a certain way. It is usable, just like rows and columns, just a different way of thinking about data. All right, here we're going to try and blow minds a little bit, because I was talking about schemas. And this is one of the main bottlenecks of data warehousing in the past, is that when I wanted to create a little star schema or a little data mart for someone, think of the top methodology here along the top line. I had to understand all the relationships between that data, all the joins, how it should be structured, rows and columns, before I even loaded data in, right? And data changes so much now, and we've got so much, it's varied, the volumes are crazy. We've got 100 different sources for data. That's a never-ending job, and so you couldn't possibly build a data warehouse like the way we used to now. So with ELT, the concept is that we load all the data, and then we only impose a schema in this middle transform step here in the very middle of the diagram. Hopefully you can see my mouse on the broadcast. If not, that's okay. But that middle where the 2 funnels get joined together, we're only transforming and imposing a schema on the data that we need. If we stay in the bottom row, we're imposing a schema when we ask for that data. And like some level of imposing this is always needed. But this is the way that things are done right now, and I'm gonna show you how I think of this in terms of imposing schemas. Okay, 2 different ways that we refer to this: schema on read and schema on write. And so this really allows us to get rid of those bottlenecks of old school ETL and data warehousing, which was that red step of applying one giant schema that applies to all our data. And instead, we're just going to apply a schema. When I say schema, I literally just mean like, renaming columns, joining tables together, applying some business rules and structure to it. We're only going to do that for the specific case that we need. And then if we get to keep that schema, that's great. Somebody can repeat it. But this is going to allow you to make your data mart creation more granular. And this is really the modern way of thinking about data. And data warehouses, let's talk computer science for a second here. I think you're going to find this really interesting, even if you're not really into this sort of stuff at a deep technical level. This is what makes the cloud so different when it comes to data curation. So nowadays, the abstraction of the the this warehouse in the middle is detached from the consumption and the ingestion. With a traditional database, so everything you see in the middle here would have been one computer or a number of computers tied together, but we really had this tight coupling of computing and storage. So think of your laptop. Imagine you could not open it up and you wanted to upgrade, like you'd have to upgrade the entire machine, right? Most of the time with laptops, you're avoiding your warranty if you do that anyway. So the cloud, because we've got these massive data centers, which are just a bunch of disks, and then we've got a bunch of massive computing engines, which are just processors, we had a physical separation of storage and compute. Now we're making a logical separation between storage and compute too. So why is this important? Well, look at this example, even just on the screen right here. I've got 3 different workloads, my virtual warehouses. My one little warehouse might be very cheap. It might be for financial reporting. My 2 might be for my data science team, and my 3 horsepower one might be for my daily loads. Let's go a little bit deeper on this to show how we can configure these things. What we're trying to do is separate the workloads for each of these, and I'm sure you've seen this before. My report is running slow. Oh, that's because they're reloading the data warehouse right now, or marketing is running some massive query on the database and it's slowing it down. We don't have to do that anymore. We can separate all those workloads. And so when you log in and you're a finance user and you ask the database a question, it says, oh, you're a finance user, you're going to use this engine and it's got 2 processors in it and it costs $5 an hour, and that gets charged to the finance department. So we can separate it. It can get very, very granular with how we chop up our computing resources because we have separated those computing resources from the underlying data. All 4 of these worker nodes here, so our data science, our finance, our marketing, and our data loading warehouses, they're all touching the same piece of data. And that's don't worry, that's handled with the technology, but we've separated the actual engine, which is really, really cool. And look how controlled we can get. So look on the right hand side here. I'm going to go top to bottom. So I've created my finance engine here. Okay, I've sized it. It's small, so it's got 2 nodes to it, right? I've told it that if it gets really busy, that it could create 2 other copies of itself. So if it's month end or quarter end and we have a lot of reports to run, this thing can say, oh, and duplicate itself a number of times to handle that peak workload. And then if you look down, so minimum just says, should there ever be, you can't go less than 1. But look at auto suspend. Here's another crazy concept, is that if nobody touches that computing node, then it shuts itself off. And guess what? We're not paying anymore, right? So from a budgeting and kind of IT spend perspective, and this is what I was talking about when I talked about things being elastic, is that if nobody's running reports and it's the weekend, this thing shuts itself down. All the technology sits on a warm pool anyway. So if I run an income statement report, instantly there's a computing resource available to me. It's not like it needs to start up and think and boot up. It's already sitting there. Think of it's in a massive warm pool in a data center. I just allocate it to myself, and then I start paying for when I use it. So anyway, I think this is a really, really critical concept to understand, that the old bottlenecks of data warehousing are not there anymore. And it's actually not scary either. If you're thinking, how complicated is this? You can even write, if you're a SQL person, you could create this. Say you don't want to go in and click and create it, you can just create through SQL, for example. So here I've created a work group. I've said you can use up to 20% of my capacity. And I've said any service that logs in with ETL login, that I assign it to that work group, right? So this stuff is very straightforward to set up and allows you to get really, really granular with how you design your analytics environment. There's also really powerful concepts like Delta Lake, which is an open source transaction layer. I have good experience with it. I'd encourage you to read up on it just as a concept. I think it's important to recognize that if you don't want to get vendor locked, so if you look at the bottom and you don't want to commit to Amazon or Google or Microsoft or whatever, there are things you can do like Delta Lake, which are agnostic to wherever your data is and will provide those same kinds of services. And it makes it look very SQL-like. So, handling transactions, et cetera, up to like petabyte scales, right? So that's the whole point of the cloud, is to allow us to go big or go really, really small. Something like Delta Lake even does time travel. What is time travel? How cool is this concept? When we used to want to look at versions of our data, we had to jump through some hoops. We had to use things like slowly changing dimensions. Um, the way that the cloud works now, and data warehouses specifically in the cloud, is through a time travel kind of function where I can say select from my table as it was 60 seconds ago or 8 days ago or last month. And it version controls itself. And so I can compare how it was then and how it is now. That's not an IT function anymore, which is what it historically was. It's something I could build into my report as a user. Select from this table as of a minute ago and as of now and compare the two. So those sorts of and there's way more functions and features like that, but I thought that was really, really cool. Once we've got our data, and I know we're about halfway through, so this is a pretty good time. We are halfway through. We've got our data loaded into some sort of structure, but we haven't made it easy. If I want to go ask that data a question now, I still need to know relationships between tables. If I want all my orders for a specific date, I still need to know the tables, right? And most people don't, especially if you're a non-technical user out in the business. And so we have something called a semantic layer or a data model in between, where we're defining things like joins. We are turning unfriendly column names into very friendly column names. We are calculating fields or combining first and last name into one column. Our focus usually, it's query generation, right? And when I say that, I'm trying to find a simple way of saying that. But really what we're trying to do is translate a question that I have in my head when I'm dragging and dropping into a language that the database can understand. That's the whole point of this layer. And also to apply things like security, right? So if I should only see a certain number of rows from a table, this is generally the layer that's going to handle that. In this layer, we can also do a lot of performance tuning. So we can say, push this calculation back down to the database or the data warehouse that can do it, at scale, as opposed to trying to do it in memory in the BI environment, for example. So, I've got two examples here, Power BI and IBM Cognos, two very different structures. And we'll talk about BI tools in a second, but some of them being able to done purely on the cloud, some of them are published to the cloud, but this is your business layer. This is where database tables are translated into business-friendly concepts. When we talk about performance, I think it's important to realize that we can go directly against databases, and if you ask users, of course, that's what they'll always ask. They need real-time information. But all of these tools and environments now have optimized data sets specifically for them. This is a screenshot from Tableau's Hyperfile, which is a good example. It's a data structure that Tableau built for itself, right? And so performance is absolutely insane when you use a Hyperfile because it's optimized for the kinds of SQL or VizQL that Tableau generates. And every technology will have this sort of thing. So anytime you're talking about running reports or dashboards or insights or whatever, you should be thinking, does this need to be real time, or could part of it be handled by a data set that, say, is loaded every hour, for example? And there's a huge trade-off in terms of performance and obviously architecture decisions that need to be made. All right. So that's I wanted to try and give you a connection back to your BI environment. I think now I want to talk about something that's down at the bottom there in the green, which is data wrangling. I don't know about the term. To me, it's just data preparation or whatever. You'll see what I mean. But this is me saying, yeah, it's great that you got things into tables and they're organized really nicely. Orders are there, transaction data is there, invoices, customers, etc. There's a lot of other stuff that I would like to do with that data. So just give it to me and I've got tools to do it. And so there are tools to do that. I think data prep is this slice that really didn't exist in the mainstream a couple of years ago. A lot of this was happening off the side of a desk unofficially, kind of in shadow IT, right? It was happening in Excel or some very niche tool. And if we tried to replace this function with BI, man, we got these monster complex dynamic reports that were like, took a long time to build, but then were almost impossible to support after. And so again, what we're trying to do here is put data in the hands of those who need it most, right? So you as a domain expert, somebody who is in marketing, you don't have to explain this very specific scientific marketing function you need to perform back to me, the report developer. You can build a very specific workflow for that, right? So that's the last mile of tuning and modeling that data, finessing that data set, or generating data like forecasts or segmentations. And then what we're trying to do is take that. So you're the expert in marketing and you've got this really great demand forecasting model. That would have died in your Excel model on your desktop a couple of years ago. What we're trying to do is encourage people to take that logic. If you look in the bottom right here, for example, at that model, it's very complicated, but if that's your demand forecast, publish it. And then say, okay, anybody that has a data set with these rows and columns, say you run a different product segment, you can run the demand forecast workflow. And this has been stamped by marketing as a valid methodology. Run your data through it, and hey, amazing, you've got a demand forecast in 30 seconds now, as opposed to having to repeat this. So really, when we're talking about data prep, it's great to be able to take data this last mile, but the real important part of it is being able to duplicate and replicate that over and over again. So automating workflows. And this is what it looks like. This is a tool called Alteryx. It's a pretty good example because it allows me to publish those kind of workflows you were just looking at into a gallery. And so as a user, I can go in and say, hey, I'm looking for something that is customer attrition or a customer retention model. And I've got a whole cohort of customers I'm really interested in. It's people who haven't bought anything in 120 days in Winnipeg, and I want to run a campaign there. So I select those attributes, I run it through the model, and away it goes, right? So, we're using the same methodology. It's repeatable. It's the whole point of process automation. This is where I get to ask my first poll, because, we didn't really get to see that tier of data usage and data work in the last couple of years. It still hasn't been deployed mainstream in a bunch of organizations. And so I'm super curious how many people, let me see if I can run this here. Select a poll. What do you think would help you do more with your data? It's not a loaded question, but I'm super curious what people would say. So doing data preparation yourself, being able to do easy predictions with that data. So something more data science focused, if you've been looking not just for rear view mirror looking things, and then being able to share it. So, this is a massive one, just having data sitting around in folders and being able to more easily share that. I guess I made you pick one. Should have said both or all of the above. Got commitment issues. That's good. All right, I'm going to close it. 3, vote. 3, 2. Wow, almost everybody. Good for you. All right, let's share this. So pretty interesting. I think most people. It's interesting that the data science kind of advanced analytics statistics one won out, because I think that's a super cool concept. I get a bunch of historical data out of my data warehouse. It'd be amazing if I could use that and say, okay, forecast what's going to happen. When should I have inventory on hand? And be able to do that myself. I think that's really interesting. Thanks for voting. I will hide that and we'll move on to the next one. All right. So kind of continuing on the story of being able to deploy and share, I think it's really important to talk about, you've got a lot of BI environments that you have right now, I'm sure. What are the ways that we are deploying analytics to users these days? So we've got a couple of different ways. If we think about where these applications are hosted to actually get data into people's hands, you've got something like Power BI, which is I build on my desktop. I'm creating my data models in this desktop tool, and then I'm publishing to a service out there, very much like we just talked about, this kind of build local and publish model. And then you've got things like Cognos and some other tools, which are pure cloud. So I'm doing my modeling and I'm doing all my development right there in a browser, like you can see. And so it just depends. I think one of the things to consider with the cloud, obviously, we talked about this before with training, is just that, that dashboard on the right-hand side, some of those buttons, might look a little bit different tomorrow because IBM decided to push an update, right? Or something changed, or there's a new feature and function there. So how do I make sure my users are always up to speed on the latest features and layout? It is a consideration for sure. But so just remember a couple of different models now that we deploy analytics with. This is definitely one of the top conversations that we have right now, which is embedded analytics. So not having to go and open a separate application to see data. Remember, our goal as data workers, right, is to get data into the hands of the people who need it most, when they need it most, in the format they need it, right? So with embedded, what we're trying to do is work towards integrating all these analytical capabilities into applications they use on a daily basis. So why should I have to go run a customer churn report? Why don't I just embed that right into Salesforce, right? And have it as a separate tab, or into Teams or whatever you use. Embedded is definitely one of the top slices that people are saying they're going to take on this year. And I understand why. Why should we have a separate page for our dashboard now? It should be sitting right there when I need to make a decision, right? Not disrupting our users' routines, no slowing down and switching to a new application or learning how a new tool and seeing, SciSense at the top and being like, what is this? Rather embedding it into something, right? So again, trying to cut down latency between the moment I need to make a decision and getting the information I need to make that call. In the spirit of taking down barriers to analysis, this is another emerging and now mature part of the analytics tool market, which is natural language, kind of AI driven, making suggestions. People are very good at Google and finding the results we need. Why not apply that same concept to data, predicting what people are going to ask for, showing them suggestions on what other people have searched for, making sure that whatever they are asking for is actually a valid question for our data set, and not getting blank rows back, right? So translating natural questions like you're seeing right now into something technical that can go back and give us results. So this is really, really cool. And these platforms, it looks simple in an animation, but it does take a lot of computing horsepower. There's some very, very complex machine learning models that sit underneath that to be trained to say, most of the time when people are saying chip, they mean chip area, and having those models constantly train over billions of rows. And so it's no wonder that the companies like ThoughtSpot, look who they partner with, right? They partner with the big computing organizations because that makes their product possible. They're taking a lot of their analytics and pushing it down into those structures that can elastically go and get a bunch of answers and then surface it back up through the tool. So I think that's really neat. This is definitely a part that maybe we don't even define the joins between tables anymore. That's possible. These models can learn to detect relationships between tables. And so we're getting past this whole I've got to model it and prepare and spoon feed the tools this perfect data set. The tools are smart enough to learn now. When people ask a couple of times, it senses it, and now it's going to make it as a suggestion. This is really awesome. I'm super excited for this part of analytics. So this brings me to my next question, which is, which one of these do you think would actually move analytics forward at your organization? Embedding analytics where people need it most in those applications and corporate applications that you're using on a daily basis, or something that removes the barrier for non-technical users and say, show me revenue for the last 5 years by province, and just having the engine figure that out and replace and send me results. Good, over half voted already. You guys are very active. Thank you. I always give it 45 seconds in case you haven't noticed. So that's 10 more seconds for everybody to vote. There's almost everybody. Amazing. I totally agree. It's both, because they both have their place in the organization. And no wonder both of those, I featured both of those in our kind of looking forward, because I think we've got a handle on the dragging and dropping, creating joins between tables. What we haven't done a good job of yet is saying, turning natural language into our translation tool. I think that's really cool. So amazing. I'm glad you all agree with me. That's a big assumption, but all right, so let's jump into the very last mile of this, which is data science. And man, if there's a term that doesn't get more controversy when we bring it up in accounts, I think much like data lake, everybody's there's some fatigue around the word data science. I'm going to try and make it way less elitist for you and break it down and hopefully inspire you to go do some data science yourself, because for sure it's way more accessible than all the blogs and influencers and tech companies would have you believe. Some are really good at saying, hey, it's for everybody, and that's the tone I want to carry through here. But really, to understand data science is to understand why we do analytics at all. And really, there's two reasons that we are doing what we do right now. We are trying to, on the left-hand side, all the things I've talked about with modern analytics, right? Minimal or no IT intervention, making sure data is ready for people who need it most. It's intent driven, so it's less about, oh, you want to see those two tables together, but it's saying, oh, you've dragged those two attributes together. We're going to suggest that you look at it in this type of visualization because that's the most appropriate, or that's what our models have seen people do most often. And so, self-serve is something we're really trying to drive towards. And then automation. So not a human dragging and dropping, but a model that is learning off of data that we are feeding it. It's watching and learning, seeing patterns, whether we are training it or it is looking for patterns in and of itself. We are automating tasks on all types of data. So at Newcomp, this is how we split our thinking when we say, what kind of problem are we trying to deal with here? And data science really happens on the right-hand side of this diagram. And the cloud has had a massive impact on that, both good, mostly good, but initially it's a little scary because it looks overwhelming. There's all these services available to us as we go to build some of these models, networking and virtual machines and authentication and cognitive services. It can be very overwhelming, but also it can do some really amazing things. Data science used to mean a science project, right? It used to mean bring the tools and libraries and packages and data and models and build it yourself, usually through Python or some script on your desktop. But data science right now looks way more like what reporting looked like to everybody and dashboards looked like, right? It's all abstracted now. And I think hopefully seeing animations like this, and I'm going to show you a bunch of examples, but it's going to coach you and say, here's a suggested chart for this type of analysis that you're trying to do. It's a graph database. You should really be looking at like a network diagram that shows relationships. You're ready to save that model and turn it over into production. Go ahead and publish it. We'll watch and make sure that it doesn't drift over time. And if it does, we'll send you an alert. So as a data scientist, man, I used to have to configure all of that myself. This is an example from something called IBM Watson Studio, which is really a studio. It's a workspace or a workbench for data science, and the cloud has allowed us to do that. You want to instantiate some machine learning service, click the button and away it goes. And so that's how data science has been changed by the cloud. And of how deeply open source has been embraced. I'm going to show you a bunch of these things later. But in the spirit of, if you're saying, we're not an in this example, we're not an IBM shop. We don't use IBM tools. Whatever, use the tool to go generate it, and you could download it as a TensorFlow model, which I'll show you in a second, which you could deploy anywhere. So open source has been embraced by everyone. It also unlocks the potential for taking advantage of massive computing power and global data. So you used to train models on your own data. Let's say you're trying to recognize a truck that has come onto your property. So if you don't have a million pictures of trucks to train the model, the internet does, the world does, and a lot of these models have already been pre-trained for you. And so, what we're taking advantage of is both massive computing resources and all the data that has been used. That's why Tesla is winning the self-driving car war, because they collect so much data, more than anybody else, right? So now we're taking all that data and kind of democratizing it. But something like this is a tool called Data Robot. It's a data scientist in a box. Look, it's evaluating all these models. I'll wait till it refreshes here. But it's got this XGBoost rated at the top. And it's saying, this is the model that's most relevant for you. How do you want to manage your data set? We suggest that you hold back this much data. You use this much for validation. And we're going to train the data set on the rest. And away it goes. And it'll go and run, 100 different models and say this one gives the best results. So that data scientist in a box is what the cloud provides for us. It's our secret weapon. If you're going to ask us to come in and do a demand forecast for some of your products sales, if you're going to ask NewComp to come in, you better believe I'm going to use these tools to accelerate it. Otherwise, it's 2 weeks of me gathering data and installing tools and configuring parameters. Now I'm just going to use tools like this that are accessible to us and to you, right? So it's really changed the way that we do our business, and should for sure change the way that you do yours. I spoke about this a little bit later, but just this embracing of open source. IBM's amazing at this, just because they contribute to open source libraries, I don't know, like top 3 in every category. IBM's a massive research engine. And so in a tool like Watson, you can download your model as TensorFlow, or its cousin Keras, which is kind of an abstraction of TensorFlow. And so pretty amazing that you can take this, you built a little image recognition model, take it and deploy it anywhere you want. But you could probably do this on your free credits, right? This convolutional layer, pretty amazing. This would have made heads explode 5 or 6 years ago. It wouldn't have just surprised people, it would have blown their brains up, because something as complex as a neural network right here in a browser. I gave you the URL so you can go play with it after, and it's really, really cool. And so this is TensorFlow, and TensorFlow's whole point is right there at the top. Don't worry, you can't break it, right? So data science should not be elitist. And if anybody tries to tell you that I'm a data scientist, I'm the only one who can build this kind of model, you should definitely kick them out, because you can do it. And I'm going to show you ways to do it. But this is really fun to play with if you want to go learn what neural networks look like. One of the things I wanted to talk about too was some of the cognitive services that are available to you as well. So this example here is a sentiment analysis, I think. And so take an email, take a big angry email from someone in your organization, or something that you wrote and left in your drafts, and you can put it in here and it will tell you. You could even run a Myers-Briggs personality test on it. And these are all available to you as APIs. So remember when I was saying you can rely on the world's data that has gone and trained models like this? You could call this from a little script on your desktop, and anytime you get an email, it could tell you if it's angry or not, and then you could decide if you want to open it, right? So just the things that are made available to you now are amazing. And so I think that was IBM's cognitive services. Here's some of Microsoft's cognitive services. So, natural language understanding, or doing entity analytics on typed, doing speech to text or text to speech the other way, translations, image recognition or looking for faces. All of these are available to you through a single line of JSON, if you want to call it. So you just pass it the file, give it some parameters, and away you go. So this is what's trying to, we're trying to take the barrier down for data science. Here, this is a pretty fun example, and this is Microsoft, so you can go play with this one, but this is some of the image recognition as well. Things like expense receipts. You could build yourself a little expense, a little receipt scraper back when we had real receipts from the real world. So you don't have to do your expenses manually or do some scanning, right? So all of these things are available. I think that's pretty cool. And you can see, I just wanted to highlight here that it'll show you the preview and it'll show you the JSON that it's generating as well. If you've ever worked with Python or a Jupyter notebook, I'm trying to show you that it doesn't look like when you're developing these applications, it's not scary. It looks like Microsoft Word or whatever, or Gmail. And most of the scripts that for the image recognition example that I just showed, this is what the script looks like behind the scenes. So if you were to click on it, it says, oh, here's the script, and you can read through it and it's all commented really nicely and you can see how it works. So we're trying to coach people to get to that level. So let's see if I did, well, no, I'm not gonna influence your answers, but I at least want to know how many people think that this is something that they could take on, because in all honesty, I still think that data science scares people. And I wanted to show that, these interfaces are not scary. It's something that should be accessible to everybody. And if that's our mission in the next 6 months, like, I'm happy just focusing on that, because I want to make sure that people are at least trying this. Thanks everybody for voting. It's almost everybody. Cool. And all right. Yes, that's amazing. That almost half of you thought that this was way too complicated and that now you were going to go try it. So in the follow-ups that you'll see from us, I'll give you a ton of resources where you can go and just try some of the things in those screenshots. Take a data set that you have and say, go generate a forecast for me and see what happens in these platforms. And then if you want to go one level deeper and it'll say, you ask that platform, how did you do it? It'll tell you how it did it. So I think that's amazing. Thanks for voting, and that makes this whole day worth it. That makes me happy. All of this is repetition. I think we've touched a bunch of these over the last 3 weeks, but I just, from when I send this to you, I want you to remember why these things matter. So being able to instantly provision things and then shut them down, both from cost and just from ease of use, that's what the cloud does for us. APIs, so image recognition or an image classifier or a tone analyzer, I can call that from a single line from a web page or from a dashboard, from a report, from a workflow that we looked at, something like Alteryx. I can call those APIs and get an amazing answer back that would have taken me a long time to write the model for in a single line of code. So, APIs connect the world these days. As a service and elasticity kind of go hand in hand. It is not a big sell anymore to go take on modern analytics. If you want to go try a data lake service and build, I was actually just talking to a colleague this morning. You want to go try a data lake or data warehouse service, run some reports against it. You can probably do it on your free credits for when you sign up for that platform. It's so cheap to just try it. So please just try it. And containerization, we went a lot deep, but this is definitely, if you're a technology person, this has changed. The container has changed the way that we deploy applications and make the cloud possible. You'll have to pardon my Ratatouille reference here, but when things are normal, we're in Disneyland at least twice a year, and so I can't help but think that, I want everybody to think that, this isn't elitist. You can certainly do it yourself and get started. So if you think of the profile of a data scientist, it is math, computer science, and domain expertise. I'd argue that most of the people who are kind of embedded in the business who have joined us today have the domain expertise. I've tried to raise you up on some of the computer science stuff, so maybe you just need some help with math, and there's some libraries to go help you with that and make suggestions. If you're a math person and a computer science person, but you're brand new to the business world, you don't know retail or oil and gas, hey, that's great news. You can partner up with somebody who does know that, and they're going to help you interpret results from your model. So when we say data scientist, I don't necessarily like that word. I think data science is a cool concept. It doesn't mean that it's one person. You can build that diagram, that Venn diagram, from 2 or 3 different people, and then I think, kind of together you make this you combine to make this data scientist. It's pretty cool. And you have to try. You saw the poll. Half of you at least thought this was too complicated to do yourselves and now believe that you could go do it. So you definitely have to try. That was almost 3 hours over 3 weeks of a bunch of information. I really appreciate you guys taking an hour out of your days to join us. We're going to do a bunch of follow-ups sessions to this. We'll look at your feedback, so please give us feedback, and then we'll go off on tangents if there are things that anybody's interested in. Please send me emails. I got a whole bunch. If I still haven't got back to you, I apologize, but I got a whole bunch of emails from people with screenshots asking questions from everything from governance to learning to which program should I take in school. So please continue to send me emails. I really appreciate it. And that concludes our 3-part series. Hopefully you are further up the analytics maturity curve in your brain than you were when you started. If you are, then I did my job and I really appreciate it. So thank you. We'll be in touch, and that's me signing off.